Yeah, I'm very sad to be here. Actually, Léon should have been here, my co-author, to present this. It's also his slide, so bear with me if the story doesn't always align perfectly. But what we're presenting here is our paper with actually a lot of co-authors. I think that's really nice, long list. Maybe that doesn't necessarily mean that every co-author agrees to the same extent with everything that has been written, and their involvement might have been to various depths, let's say. Let's start here. And yeah, I personally also still need to get used to the age of AI generated images, but this is actually a really nice image because it for me really encapsulates what IFC in its current form, in its current serialization, its current, let's say, mainstream technology looks like. You have the potential for a very nice and rich, dense in graph terminology, a graph where you can really make relationships. But yeah, on the other hand, we have the unfortunate situation that we have inherited certain technologies that really make it very difficult to take one part out of this graph and, I don't know, use it in another model or reference it, because we all have only local identifiers. And so it is a dense information rich graph, but packaged in a monolithic container. And then I'll highlight some of the items that we have found as, let's say, limitations of this format. If I give this presentation, I always include a video from Steve Ballmer in his Microsoft days, where he is covered in sweat and he is shouting, "Developers, developers, developers, developers." He goes on longer. I will spare you that. But this developer mindshare, and the reason Ballmer brought that up is it's what they believed in. They created .NET, they bought GitHub, they created Visual Studio Code, they open sourced a lot of their development infrastructure because they believe that if the developers are there, the apps are there, and the users and the paying customers are there. And I think this is one of the challenges, what we have with IFC. A lot of people will walk away when they see paywall technologies from the 80s as let's say, the choice of serialization. Maybe not, let's say, valid, but it happens. Maybe another part, because this is maybe a bit contentious, but there's this not high level of computer interpretability, and maybe people will, maybe not everyone in the audience will agree, but a lot of things are questionable here. Like, what's the definition of a column in IFC? Well, the definition in IFC4 was a column is a load-bearing element unless it's not, because you can also have the decorative columns, right? So in terms of semantic clarity on what discriminates one building element type from another, we're just a wall of text with very fuzzy, unclear definitions. And this matters for downstream usage, right? If you want all columns, then you at least need to agree on what that means for a specific use case. And I think especially in the earlier days, maybe 5-10 years ago, we also had really a lot of robustness and reliability issues, where one tool would render it like that and the other tool would render it in another way. In a way, you already see this evolution in the IFC specification, that in terms of geometry, IFC4 is much more explicit than IFC2 Extreme. Now, in this look on history, there's a couple of things I want to highlight. Well, we all love our acronyms. especially if there are 3 letters. But so there is a USD here in the middle. That's Universal Scene Description. That's Pixar created that, and that's how they build, I don't know, all the Disney Pixar movies with very diffuse multidisciplinary teams working towards one digital artifact. The other concept there is ECS, Entity Component System, which basically advocates for, let's not create deep inheritance trees, you know, where a wall is an element, which is a product, which is an object definition, which is an object, which is something that has a rooted, stable identity. But rather, let's just combinatorially create the semantics that we're after. And we were having dinner yesterday, and this is the example I always bring up. For a lot of use cases, it doesn't matter whether something is a column or a beam. The manufacturer just needs to extrude a profile. So this classification also, yeah, what is relevant depends on your use case. And with this ECS, you would have components. So you would have maybe a profile component and an extrusion component and a classification component. And you look at the data that you need. So the methodology here, if you can talk about that, the paper is a bit more methodological than the presentation maybe. But these requirements have been gathered throughout years, maybe even before, let's say, the modernization of IFC was really formally on the table. I'm in the interest of time, I'm not going to read all of them, but this distributed nature, that we're working collaboratively towards one artifact, or at least, multiple views on the artifact coexisting, that is really a key requirement, and it really traces back to that monolithic graph encapsulation that, you know, you just have these graphs side by side, but there's very little means for creating rich coupling between the silos, and we call them silos then. And at the same time, throughout the different axes, if we have this problem along the axis of multidisciplinarity, we also have that problem in the axis of time. We don't have incremental updates. You can only send the full file again with that change, which means you need to invest a lot in, let's say, post hoc diffing to see, okay, what actually changed in this new model. Okay, extensibility, modernness, we talked about the developer feel. And then, this is the ECS idea, more atomic, predictable data patterns, reliability, robustness, so more focus on the explicit data with semantic richness as additional layers on top. Now, I need to speed up a bit. So this narrow waist idea is a key concept. You also see it in the sockets, for example. It doesn't matter what generates the electricity, solar, wind. It doesn't matter if I'm drying my hair or heating my food. It's a very narrow interface, this socket. You just have the same with IP. You can have internet protocol over homing pigeons even with a USB stick to their feet, and it works. It's a protocol. Same image. Now, in the end, and this is then the technical realization of what we came up with, and in all the dinners we had, this is also where there is a disconnect where we still need to work on. So how do these requirements really, how are these the necessary cause of what exists in children, basically decomposition, inheritance, how information can be broadcasted over nodes, for example, for, let's say, typical objects, and a wall or window type, that information literally carries over through its occurrences and attributes, let's say, schema-driven components. I have to speed up, I think. So layers is a really great analogy. So these layers can be viewed in isolation. They're not divs. This I will skip. And then more with overrides. This is you can locally override information because little facts, they have a strength. So the more locally they are defined on the element, the stronger the opinion is. So we have incremental updates and yeah, different opinions. And what unifies all of this, whether it's across disciplines or across time, is this idea of composition that we derived from USD. Thanks so much. That was